Science Galaxy. Welcome to our channel Science Galaxy, where we learn science in simple ways. Don't forget to like, subscribe and share the video.
Hello students, let's move further in our topic vectors. We would start with the topic speed. So what is a speed? Speed is the distance traveled per second by the object. It means it is the distance covered in unit time by the object. For example, if I say my speed is 5 meter per second, it means that in 1 second I could cover a distance of 5 meters. If I say my speed is 12 kilometer per hour, it means that in 1 hour I could cover a distance of 12 kilometers. There is a device in all vehicles called speedometer. Speedometer tells us about the speed of the vehicle. For example, the meter if reads 12 km per hour, that means the speed at that very instant is 12 km per hour. But it does not tell us the direction about the motion. It could be east, west, north or south. It just tells how much distance do we cover in that particular time, but it does not tell about the direction. Even if we turn and we accelerate the motion, the speed would increase. So speedometer just tells us about the speed of the object and it does not tell us about the direction of motion. Speed is a scalar quantity. It does not depend on the direction of motion. So speedometer tells us about the speed of the vehicle. Speedometer tells only about the speed at that very instant. At that particular time, what was the speed? It does not tell us about the average speed of the vehicle. For example, if I accelerated my vehicle, then my speed would increase. In whole of the motion, my speed would increase, decrease or became zero also at various instants. But the average speed is different from this speed. Average speed would mean the total distance I covered upon total time taken. For example, if my average speed was 15 km per hour, that does not mean that at every instant I was moving at 5 km per hour. That just means that in the whole path, my average speed came out to be 15 km per hour. During the motion, I might have increased the speed or decreased the speed. So my instantaneous speed is different from average speed if my motion is non-uniform. Non-uniform motion means speed is increasing also and speed is decreasing also. So the average speed is total distance covered upon total time taken. This is what we call speed. Speed does not give any information about the direction. But if we include direction also, then it is called velocity. Speed is just the magnitude with its unit. For example, 5 meter per second. Here 5 is the magnitude, whereas meter per second is unit. It does not contain direction, but if I say my speed is 5 meter per second in the north direction, it gives us the velocity. Velocity is the distance covered by the object in 1 second in a particular direction. What is velocity? Velocity is a speed with direction. That means distance covered by the object per second in a particular direction. But we very well know about displacement. Displacement is the distance covered in a particular direction. So we can say distance covered in a particular direction means displacement. So what is velocity? Velocity is displacement per second. How much displacement has been covered in unit time is called displacement. Average velocity is total displacement upon total time. Velocity is a vector quantity because it depends on magnitude as well as direction. It means it contains three things: magnitude, its unit, and as well as its direction. For example, 5 meter per second in the north direction. It contains 5 as the magnitude, meter per second as the unit, and in the north direction it is the direction. So velocity is a vector quantity. Let us consider an object. It was at the position x1 at time t1 initially. Now the object moved a certain distance, and now the object is at point x2 at time t2. Object was initially at x1. Now the object moved a certain distance, and now the object is at point x2 at time t2. So what will be the average velocity? Average velocity will be total displacement upon total time. If I say the object was at 10 centimeter, now it moved to 30 centimeter. How much distance it covered? How much displacement it covered? It covered 20 centimeter. x2 minus x1 means 30 minus 10. And time. If initial time was 2 seconds, initially at 10 centimeter at 2 seconds. It was at 10 centimeter in the time duration 2 seconds. Now it moved a distance of or displacement of 10 centimeter more. It came at 30 centimeter in 30 seconds. So we would the average speed would be total displacement upon total time. That means x2 minus x1 upon t2 minus t1. Okay, we very well know that displacement is generally less than that of distance. Displacement is the shortest distance between initial and final points. So obviously displacement is less than distance, except the case when we do not change the direction. If we do not change the direction, we move in a single direction only, then in that case the distance as well as displacement is equal. Otherwise displacement is always less than distance. Similarly, our speed is always greater than our velocity, or we can say that velocity is always less than speed. Exception is when we do not change the direction. If we do not change the direction, then speed is equal to velocity. Now let us take one example. There is a person Ram. Ram moves from point O to point P, in interval of 18 seconds. Then it moves from P to Q in 6 seconds. He moved from O to P in 18 seconds. This happened in the interval of 18 seconds. Then from Q to P in another 6 seconds. It means from O to P he took 18 seconds, then P to Q he took 6 seconds. We have to find the average velocity and the average speed in this case. Now we will think about distance and displacement. What is average velocity? Average velocity is displacement upon time, while average speed is distance upon time. So if he went from O to P, distance would be 360, and from P to Q, distance would be 120 more, because from 240 to 360, 120 distance. This distance is 120. And this distance is 360. And then he went 120 more distance. So the total distance covered in this case will be 360 plus 120, that is 480. He covered 480 meter distance in how much time? He took first 18 seconds and then 6 more seconds. So total time taken by him is 24 seconds. He covered a distance of 360 meters in the time interval of 24 seconds. He took 24 seconds. So the distance would be 360 plus 120, 480, while the time taken is 24 seconds. We would divide the two, 480 by 24, and that would come out to be 20 meter per second. Speed is distance upon time. Distance is 480 and time is 24 seconds. Now let us talk about displacement. Displacement is the shortest distance between initial and final position. Initial and final position 0 and 240. What is the displacement? Although he moved like this and then came like this, but the shortest distance between O and Q would be OQ, and that is 240. So the displacement is 240, and time taken is same, first 18 seconds, then 6 seconds. Time taken is 24 seconds, so average velocity comes out to be 10 meter per second. Here we can see that average speed is greater than average velocity. Let us take one more example in which Ram does not change its position. He just went from O to P and he didn't change any direction. He just moved in a straight line path from O to P. Here distance is 360 as well as displacement is 360. Shortest distance is also 360 and the length of actual path covered is also 360. So average speed would be 360 and he moved from O to P in 18 seconds. In this case, average speed as well as average velocity will come out to be 20 meter per second. That means in this case, average velocity equals to average speed if he doesn't change the direction. Also, had he came back to the point O, had he gone through this, then came from P to Q and then returned to point O, in this case displacement would be 0, and if displacement is 0, his average velocity would also be 0. If we return to the same point after covering as much distance as we could, but if we returned to the same point, then our displacement would be 0, and if displacement is 0, the average velocity is also 0. Now we can understand that speedometer tells us about the speed only, because if we came to same point also, if we started from home, from our house, then went to our school, then came back to our house, it does not mean that the velocity would turn out to be 0, but the speed would not be 0. So speedometer tells us about the instantaneous speed. Now let us take one more question. The question is it possible to move with constant speed but not constant velocity? It is the first part. Is it possible to move with constant speed but not constant velocity? Second part is it possible to move with constant velocity but not constant speed? Now first let us discuss the first question. What do we mean by speed? Speed is only the magnitude, while velocity contains magnitude as well as direction. So it is possible to move with constant speed. For example, I am moving with 5 meter per second, and if I change my direction continuously, but speed is a scalar quantity, speed does not depend on the direction. So speed is constant, that is 5 meter per second. Its magnitude is constant, but I am changing my direction. If I change my direction, the velocity also changes. If I change my direction, velocity also changes. So if I continuously change my direction and move with a constant magnitude, So I would have constant speed, but not constant velocity. My velocity would be variable. For example, I was doing uniform circular motion. In the uniform circular motion, at every instant, my direction of motion was changing. At this point, this was my direction of motion. At this point, this was my direction of motion. But I was constantly moving with 5 meters per second. So my speed is constant, but my velocity is variable. My velocity is variable in this case. Now the second question is it possible to move with constant velocity? Constant velocity means velocity depends on two, magnitude as well as direction. Constant velocity means we would have same magnitude and the same direction. We should have same magnitude and the same direction. But not constant speed. It is not possible. Constant velocity. It is not possible to move with constant velocity, but with constant speed, because if we move with constant velocity, it means constant magnitude as well as constant direction. And if we move in a constant magnitude, then we would have constant speed also. Let us read about the answer. No. Constant velocity means direction as well as magnitude remains to be same. Magnitude of velocity is the speed. Hence, if velocity is constant, speed also remains to be same. I hope you understand this topic. Now let us move to another question. Find velocity and speed of a minute hand of length 14 centimeter in one round. We know about the minute hand in our clock. The minute hand covers one rotation in 60 minutes. Also, the length of minute hand would mean radius of the clock. Consider this to be a clock. This is the minute hand. It is 14 centimeter long. It covers one round. We need to tell about the average velocity and the speed. Now, the distance covered by the object by the minute hand is 2 pi r. In a circular motion, in one rotation, how much distance do we cover? We cover a distance of 2 pi r. If we solve this comes out to be 88 centimeter. While the displacement is 0 in one rotation because our initial and final positions are same. If our initial and final positions are same, then the displacement would come out to be 0. Now we know speed is distance upon time. So distance is 88 centimeter. Time is 60 minutes. If we want, we could convert it into meter per second. We could divide this by 100 and convert it into meter, and multiply this by 60 to convert it into second. But it is not necessary. We could leave answer in centimeter per minute also. That's no problem. So for one round, we know time is 60 minutes. So 60 minutes time, and the distance is 88 centimeters. Speed is 88 upon 60. While velocity will be 0. Why? Because displacement was 0. In one rotation, displacement would be 0 because its initial and final positions would be same. Now let's move on to our next question. Sia moved 2 km east, then 3 km north, and then 2 km east. We need to find distance as well as displacement. Now let us consider Sia to be at position A. At point A, Sia started to move 2 km in the east direction. Sia moved 2 km in east. Then she moved 3 km toward north, and then 2 km towards east. So finally, Sia moved from AB, then B to C, then C to D. We need to find distance as well as displacement. Distance would be 2 plus 3 plus 2, the length of actual path covered, while the displacement would be shortest distance between the initial and final position. Our initial position is A, our final position is D. So the displacement would be AD. Now we need to find the displacement. Displacement is AD. Now how can we find this distance AD? We need to produce these two lines to meet at a point O. Now if this distance is 3, then this distance would also be 3. This distance is 2, then this distance would also be 2. Now, this is 3, this is 2 and this is 2. In this triangle, if we apply Pythagoras, whole OA would come out to be 2 plus 2, 4 and OD is 3. We know by Pythagoras theorem, AD square equals to OD square plus AO square. Means 3 square plus 4 square. That would come out to be AD square is equal to 25 or AD is equal to 5 kilometers. So the displacement would be 5 kilometer while the displacement is 7 kilometer. Here also we can see that displacement is less than distance. Now we have cleared our concept that distance is always greater than the displacement, except the case if we do not change the direction. If we do not change the direction, then distance and displacement comes out to be equal. Now we are going to study a next topic, acceleration. What is acceleration? We were discussing about uniform speed and non-uniform speed. Speedometer tells us about the instantaneous speed but not the average speed. If our average speed was 20 km per hour, but sometimes I moved with 10 km per hour and other time I moved 30 km per hour, then my speed was not uniform. Sometimes I was increasing my speed and other times I was decreasing my speed or velocity. So the change of velocity upon time taken is called the acceleration. What is acceleration? Acceleration is rate of change of velocity. At what rate I was changing my speed, my velocity is called the acceleration. Consider I was moving initially with speed u or velocity u. U is my initial speed. Initially I was moving with u kilometer. I increased or decreased my speed and now my speed became v. V is my final position, final velocity. After accelerating it or applying brakes, so change in velocity would come out to be v minus u and the time taken is t. Acceleration is equal to change in velocity upon time. What is acceleration? Acceleration is the rate of change of velocity. What is the change of velocity? V minus u. Rate means upon time. So acceleration would come out to be v minus u upon t. If the object moves with constant velocity means both. No change in direction, no change in magnitude, because velocity depends on two things, direction as well as magnitude. So constant velocity means at a constant direction with a constant magnitude, the acceleration will come out to be 0. That means v is equal to u If we are moving with constant velocity, we are not changing our velocity, then the acceleration would come out to be 0, because what is acceleration? Acceleration is change in velocity upon time. If our initial and final velocities are same, if v is equal to u, then acceleration would come out to be 0. If we move with constant velocity, that is, we do not change our magnitude or direction, then acceleration will come out to be 0. For example, I was moving 5 meters per second in the north direction in a straight highway, and I kept moving. I did not accelerate my motion. I didn't even apply the brakes. I just moved at the uniform velocity of 5 meters per second in the same direction. Then the acceleration would be equal to 0. In the constant velocity, acceleration equal to 0. What is acceleration? Acceleration is rate of change of velocity. If the object increase the speed constantly, for example, my velocity is increasing. Every second I increase my velocity by 2 meters per second. That means at first I was moving with 20 meters per second. Then I accelerated my motion. Another second my speed would be 22 meters per second. Then 24 meter per second. Then 26 meters per second, and so on. Every second I increase my speed by 2 meters per second. That would mean my acceleration is 2 meters per second square. If the object constantly increases its speed, that means every second the speed is increasing by constant magnitude, then it is accelerating. If the object is constantly reducing its speed, for example 20 meters per second, then 18 meters per second, then 16 meters per second, 20 meters per second, it is reducing its speed every second by constant magnitude. That would mean, how can we decrease our speed velocity? By applying brakes. That would mean our acceleration is negative. Negative acceleration is called retardation. What is the negative acceleration? Negative acceleration is retardation. It is also possible that object move with constant speed, but then also it is accelerating. It is possible that object move with constant speed but is accelerating. But we now only said that if object moves with constant velocity, for example, the object was moving with 5 meters per second. In this 5 meters per second, then the acceleration was 0. No, this is incomplete. We said if the object moved 5 meters per second in the straight path, if it did not change its direction, then the acceleration is 0. So it is possible that object move with constant speed, that is 5 meters per second, but it constantly changes its direction. If it changes its direction, its velocity also changes, because velocity depends on magnitude as well as direction. So its velocity will change, and then the acceleration would not be 0. For example, consider uniform circular motion. I was moving with 5 meters per second speed only, but in a circular motion I was changing my path, changing my direction, and if I changed my direction, my velocity will be changed, and if velocity changes, then acceleration is not equal to 0. Now let us try one question. A car travels along a straight highway with constant speed of 20 meters per second. In a straight highway, the direction would remain same, as well as the magnitude is the same. So what would be the acceleration? If same magnitude and same direction means same velocity, and if velocity remains to be same, the acceleration becomes 0. So now the acceleration is 0. If a car moves along a straight highway means it does not change its direction with a constant speed means it does not change its magnitude, then the acceleration would be 0. If one of the thing, either the magnitude or the direction changes, then the acceleration would not come out to be 0. Now the B part is, if in 3 seconds the speed became 32 meters per second, find the acceleration. Its speed initially was 20 meters per second, that is u. U was 20 meters per second. Its final speed became 32 meters per second in the time interval of 3 seconds. We know about a formula that acceleration is equal to v minus u upon t. Here v is 32 meters per second, u is 20 meters per second, and time taken is 3 seconds. So the acceleration would be 4 meters per second square. Now another part of this question, if in 2 seconds speed became 12 meters per second, find the acceleration. Now it was initially moving with 20 meters per second. Now in the time interval of 2 seconds, the speed became 12 meters per second. Initially, the object was moving with 20 meters per second. U was 20 meters per second. In time interval of 2 seconds, the speed became 12 meters per second. Acceleration is equal to v minus u upon t. It would definitely come out to be negative because the speed is decreasing. And negative acceleration would mean retardation.
Thanks for watching the video. I hope you like it. Don't forget to like, share, comment and subscribe.
Here are some more interesting videos and vectors first part you may access through.